In this video, we'll be considering u substitution problems where we are trying to evaluate some sort of definite integral. And it turns out that there's two ways to solve a definite integral using u substitution. One way is to just imagine that the integral that you are working with is an indefinite integral and solve it just like you normally would, get the variable back in terms of x's, and plug in your original limits of integration. But the other way we are going to show in this video is the one that I prefer, where we will change to the variable u and we will also change our limits of integration. So in this problem, we're going to do a u substitution where u is equal to 3x plus 4, since that's inside of the square root function. That will give us du, which is 3 dx. And when we do our substitution in this case, the square root of 3x plus 4 becomes root u, and the only thing we have left is the dx. So what we're going to do is we're going to take this du equation here, we're going to divide both sides by 3, and we have 1/3 du is equal to just dx. So I can take that 1/3, pull it out front, and what I have is 1/3 times the integral of square root of u du. Now, you'll notice that I've left off the limits of integration, and the reason is because these limits of integration, 0 and 4, are for the variable x. And this new variable that we have is u. So what we need to do is figure out what are our new limits of integration. So what we're going to do is we're going to utilize this u equation that we have from before in order to figure out what our new limits of integration are in terms of u. If we plug those values, x equals 0 and x equals 4, into the u equation, then we find that the new lower limit is u equaling 4, and the new upper limit is u equaling 16. So our new integral is 1/3 times the integral from 4 to 16 of the square root of u du. And you'll notice here that we have completely changed the variable from x to u, which is why we have completely changed our limits of integration. So now we have 1/3 times the integral from 4 to 16 of the square root of u du, and the rest of this problem will be solved normally, in that we do not have to go back to that original variable x. Everything now is in terms of the variable u. So after integrating u to the 1/2 and substituting in 16 and 4 and performing the subtraction and the arithmetic, we get 112/9. So in this problem, we had two ways of solving it. One, we could have done the original problem as if it were an indefinite integral and then plug in the original limits of integration, or we can change to our new limits of integration and not go back to the original variable, and stick with the new limits of integration and work the rest of the problem with the new variable u.